Section 3.5 is operations of functions, and in this section we're going to be learning how to form sum, difference, product, and quotients and find their domain, and we're also going to be working with composite functions and finding the domains of those composite functions. So we're going to start out talking about sum and difference functions. So sum and difference functions would be, for example, let's say you have the function f of x like we have here and g of x, and I ask you to find f plus g, and then also find the domain of that. So the idea of finding f plus g is actually pretty simple, but the domain of it, we're going to move on and talk about the finding the domain of that, and actually not just sum, difference, product, and quotients. And then we're going to go back to the previous slide. So if you have these two functions and you're finding the domain, anytime you're dealing with a sum or a difference or a product or a quotient, all you have to do is find the domain for your f of x, find the domain for your g of x, and then find where those two overlap. The overlapping area is going to be the domain of that sum, difference, product, or quotient. Now, there is an exception for the quotient functions. You have to remember that you do not want a zero in the denominator. So most of the time, they're going to be times when for example, let's say g of x is in the denominator, and you'll see this in a minute, you have to say, well, your x squared minus 1 is greater than 0 as opposed to the greater than or equal to 0 when that happens to be in the denominator. So let's go through and find the domains of each of these. So if we have f of x, then the domain of this, we're going to say 1 minus x is greater than or equal to 0, which means that x is less than or equal to 1. So we have the domain of your f of x, and then the domain of our g of x is going to be x squared minus 1 is greater than or equal to 0, and I don't need that parenthesis. So you notice that you have an inequality, and the exponent there is greater than 1, so we need to factor, and we're going to have to use test points in this case. So on a number line, the test points are the points that I'm going to use. My critical points are going to be -1 and 1. And I know I have closed circles on these because it can be equal to those, and I need to figure out what's happening in each area. So if I were to choose a 0 and I plug in 0, then I'd get a -1 in the first parenthesis and a +1 in the second parenthesis, and that's going to give me -1. And is -1 greater than or equal to 0? It is not. So this area does not work for us. Okay, so then we want to try the other areas, and if you choose something in the other areas, you actually notice it does work. And so we get this. And so that gives you the domain of your g of x. Now if we add to that this here, and I'm going to add it in blue. Okay, so I'm going to add to this in blue. X is less than or equal to 1. So less than or equal to 1 is going to be here. All right, so now I'm looking for the combination of those two, and then that's going to be the domain that I'm looking for. So if you look where they overlap, they're going to overlap in this area and continue, and then they also overlap in this area. So the way we would write that is that we would say from -infinity up to -1, including -1, and then also at 1, but it stops and ends at 1, and it includes 1, so that one's a little tricky. All right, so that's going to be the domain for the sum, difference, and product quotients. Now, when we have the quotient, we're going to have to come back and make some adjustments to this, and we'll do that in just a few minutes. All right, so now let's go back here. Now that we know how to find the domain, let's go ahead and do the easier part, which is just to find f plus g. So f plus g of x, that can be rewritten as f of x plus g of x. And so we just need to say f of x is the square root of 1 minus x, and g of x is square root of x squared minus 1. And that's all we can do. And the domain is just going to be what we found here. And so that's going to be our domain. So now let's move on and talk about the difference. The difference here. So we're working with the same f and g, and this time we want to find f minus g. Okay, so f minus g is actually going to be exactly the same as what I did here. So except for one thing is going to change. So I'm going to copy this. And so we have f minus g of x is just f of x minus g of x. And I said it was exactly the same as it was when I was adding, except for what changes. And what's changing is the plus here, because we're subtracting the two. So that should be a minus. And then when we talk about our domain, again, our domain is going to be exactly the same as it was with our sum. And so there we have our domain. All right, moving on to our quotient. Oh, I'm sorry, we're actually going to do our product first. So here we have our product, and we're finding f times g, which can be rewritten as f of x times g of x. And we just plug those in. So f of x is going to be the square root of 1 minus x. We're going to multiply that by our g of x, which is square root of x squared minus 1. Now this one we can do a little bit of simplifying, because both of those, we can simplify that to one radical, and then we're going to put both of those expressions in. And what I'm going to do is also factor the x squared minus 1 at the same time. It factors as this, because then we realize we're actually going to have pairs that can come outside. So what you should notice is that these two have exactly opposite signs of each other. And if that's the case, then I can factor out a negative 1 in one of the two. So if I factor out a negative 1, then I get negative 1 times a negative 1 plus x. And then the remainder, everything else stays the same. Okay, now the reason I did that is because now I can go and rewrite this as negative 1 times. I'm going to switch the order of the negative 1 and the positive x. That's just a commutative property. It allows me to do that. And the whole reason I did that is because now you see that we have a pair of x minus 1s. And if I have that pair of x minus 1s, then I can take it out. So the square root of that would just be x minus 1. And it has to be in parentheses, square root negative x plus 1. Okay, and so now we have that simplified. And our domain is going to be the same domain that we had previously. Okay. All right. Now we're moving on to our quotient. So the quotient, we have f over g of x, which is f of x over g of x. So this is where you should notice that g of x can't be 0. You can't have you can't have that equal to 0, because this would be undefined in that case. So what we have now is, if we just plug those in, 1 minus root x, or square root of 1 minus x over square root of x squared minus 1. And then we need to go through and see if we can simplify those. So if we simplify, we're going to do this one radical here. Just like last time, I'm going to factor out that negative 1. I'm going to go ahead and skip a step here, since we know how we would rearrange those and get this, because I know my denominator is going to factor as x plus 1 and x minus 1. So now again, you should see that the reason for doing that and factoring out that negative 1 is so that these two can cancel. And then once those two cancel, then we have the square root of negative 1 over x plus 1. This, if you were simplifying, if the directions were to simplify, then you would need to simplify this by rationalizing the denominator, which I'll do in a later slide, but I'm going to leave it like this for now. It is not completely simplified, but now let's go ahead and talk about the domain. The domain of this one is going to be slightly different than this, and let's figure out how it differs. and rewrite that. So I'm going to go back to the previous slide. So let's make a note first is that we have g of x in the denominator. Okay, so the thing that's going to change is our g of x. Okay, so here we are, and we notice that for our g of x, what we had for our g of x, we said that x squared minus 1 is greater than or equal to 0, and then we simplified that. So this right here is going to change. And the way this is going to change, I'm going to duplicate it. Okay, so the g of x is the one that we have here in red. It's going to change by these solid circles right here are going to become open circles because it doesn't have the equals to part on it. So then when we go to see what the intersection is going to be, the intersection is actually going to be not include that, but all of this area and beyond, and then and then not any of this. Okay, so that's not included. So the only thing is what we have in green here. So what that does to our domain that we had initially is it knocks this part off and it changes that to a parenthesis, and that's it. That's how it changes. Okay, so we're over here. Here we go. So we said it's going to take this part off and it's going to change this to a parenthesis. And that's going to be our domain. Okay, so here we have another example, and what you're going to do is to use this to find f times g. We're first going to go through and find the domain of these, just like so that we can use that multiple times. So let's look at the domain. First, we're going to find the domain of our f of x. So let's do that one first. In this case, we're going to say 2x is greater than or equal to 0. So that means x is greater than or equal to 0. And now let's find the domain of g of x. And domain of g of x is going to be that x squared minus 4 is greater than or equal to 0. So again, we have quadratic and an inequality. That tells us we're going to have to use test points. Okay, so we have a number line. We're going to have a -2 and a +2 on the number line. You choose your test points, and the way it's going to turn out is that this area doesn't work because that's going to produce a negative. These areas do work. Okay, so now we want to combine that with the domain of our f of x. And I should have given myself more room. So I can use that. Since I have one number line, I'm just going to put my x is greater than or equal to 0 on that. So if this is 0, and then I've got x is greater than or equal to 0, it's going this way. And then the area where they're going to overlap is going to be in here. Okay, so that means that the domain, most of the time, except for when I'm dealing with the quotient, is going to be from 2 to positive infinity, including the 2. Okay, so that's our domain there. And once I have that, now we're going to find f times g of x. Okay, so that was the original problem here. Move some of this out of my way. Okay, so my f times g of x is going to be f of x times my g of x. And in this case, we have root 2x times square root of x squared minus 4. And when I can use one radical, and I can leave it like that, or I can go ahead and multiply and get my 2x cubed minus 8x. And then, of course, my domain is what we found it to be. in the previous step, and that is here. Okay, nothing tricky with the domain on the product. Now, now we're going to look at the quotient. So the quotient, we know we're going to have to figure out the domain. We know what the f and the g are. So let's just go back over here and figure out how this is going to change. So I'm going to copy this. We know our work's going to be similar. And let's think about how this is going to change this. All right, so this time we have a g of x in the denominator again. So that means that my g of x, instead of having solid, those are going to be whole. So the black is going to be a whole, right? So instead of having this parenthesis, this bracket, we're going to have a parenthesis. And that's the only way my domain is going to change in my quotient. Okay, so now we're going to go ahead and find our quotient here. So we have f of x over g of x. And our f of x is square root of 2x over square root of x squared minus 4. And what we want to do is to simplify this one. So if I put them under one radical, use one radical and use the 2x over the x squared minus 4 as one radicand, then it's not really going to help me cancel anything out. What I notice is that I have a radical in the denominator. So I told you earlier I would rationalize this and show you how to rationalize it. You want to simplify. We want to get rid of the radical in the denominator. We're going to do that by multiplying by a fancy version of 1, because if there are 2 of the x squared minus 4s, then they can come out of the radicals. So that makes my denominator now this. And it's legal to do that because this here is just 1. And you can always multiply by 1 and get the same thing back. So in my numerator now I have 2x times the x squared minus 4. And it's fine to leave it like that. And then we talk about the domain. The domain, we've already figured that out, is going to be from 2 to infinity. Okay, so we've taken care of sum, difference, product, and quotients. Now we're going to talk about composition of functions. So that's when we do g of f of x or f of g of x. In this case, I'm going to talk about g of f of x first. So it can be written like this or like this. So your inside function is going to be your f of x. Or in this case, your g is going to be your inside function. So those are not the same. Those are two different ones. Here's an example here. So you've got your f of x and you've got your g of x, and what we're going to do is find g of f of negative 2. So this can be rewritten as g of f of negative 2. Well, first we want to focus on finding the inside. Okay, so you work from the inside out. So f of negative 2, but we're going to keep our g in place and then simplify as we're going. And I'm going to use red to talk about what I'm doing. So I'm going to my f, and everywhere I have an x in my f function, I'm inputting a negative 2. So a negative 2 squared plus 2 times negative 2 plus 1. Okay, and now I need to simplify that. And when I simplify that, I get g of 1. Okay, all that inside simplifies to g of 1. And of course, we know how to find g of 1. I just go to g. Everywhere I have an x, I'm going to input a 1. Okay, and then I simplify that, and I get negative 1/2. Okay, and that's how it simplifies. All right, so that's g of f. Now we're going to flip that around and do an example with f of g. Okay, so same two functions, f and g, and this time I'm finding f of g of 4. So again, I'm going to focus on taking care of this piece, but I'm going to leave my f in place, and I'm going to use red for everything I'm doing here. I'm going to g, and g is 1 over, I'm putting in a 4 for my x, minus 3. And when I simplify that, I get f of negative, I'm sorry, not negative, I just get f of 1. Okay, 4 minus 3 is 1. So I get f of 1. And then f of 1 is easy to find. I go to my f function, which is x squared plus 2 times x plus 1. And I'm putting in that 1 into the x spots. And then I simplify that, and I get 4. Okay, now we're going to work with compositions, just compositions of functions. So let's say I want you to find g of f of x. Okay, so that means that I need to go and actually put in f of x here. I don't have a value for x, I'm just going to use f of x. So I keep my g. My f of x is x squared plus 2x plus 1. Okay. And now that I have that, I go to my g, and everywhere I have a variable in g, I'm now going to replace it with this. So that's 1 over, there's my x, minus 3. Okay, that's my g. And then that guy is going here. So that becomes x squared plus 2x plus 1. And then from here, we just simplify. 1 over, and then I get x squared plus 2x minus 2. And this is what we're looking for. So that's g of f of x. Now we're going to take a look at f of g of x. So if I have f of g of x, I have f. G of x is going to be my inside function. And so I have f, and then I put in my g of x. So that's going to be 1 over x minus 3. Okay. And now that I have that, I am looking for f of 1 over x minus 3. So I go to my f and put, I'm just going to use parentheses everywhere I have an x. Okay, that is my f. Now everywhere I have that, I'm putting in this. So this is going to be 1 over x minus 3, and this will be 1 over x minus 3. Okay, and so I simplify, and I get 1 over x minus 3 quantity squared, because if I square 1, I get 1, plus 2 over x minus 3 plus 1. And now, and that's fine, we can leave it in that form. And so that's f of g of x. All right, now that we've talked about compositions of functions and how to come up with the composition of functions, the equation, now we're going to talk about those with the domain, finding the domain of those. So it's a little more complicated than finding just the domain of a sum, difference, product, or quotient. In this case, what you're going to do is find the domain of the g of x if you're finding f of g of x. So it might be easier to think of it as finding the domain of the inner function. So whatever's on the inside, find the domain of that. And then you find your composition, and then whatever that is, simplify it and find its domain. And then you have to find where those two overlap, just like we did previously. And when you find where those two overlap, that's going to be the domain of your composition. So let's look at an example here. Let's say I have these two functions. These two are f and g. I want to find g of f, and then I also want to find the domain. So let's just start out by finding g of f of x. Okay, so that's g of, and then f of x is going to be square root x minus 2. And then I go to my g, and wherever I have an x, I'm using parentheses, minus 1, and I'm going to put that in. So that's root x minus 2. And now I need to simplify that. When I simplify that, if I square the square root, I just get x minus 2, then minus 1, so it gives me x minus 3. Okay, so now to find the domain of this. All right, to find the domain, one, I'm going to find the domain of my inner function. In this case, that is f of x. So the domain of f of x is going to be that x minus 2 has to be greater than or equal to 0. So x is greater than or equal to 2. All right. The next thing I'm going to do is find the domain of my simplified composite function, which is going to be this guy. Okay, the domain of x minus 3. I don't have any variables in the denominator. I don't have any variables in the radicand. So this case is going to be all real numbers. So if one of the two is all real numbers, then the combination is going to be the one that's just the strictest. So that means that my domain is going to be the combination of the two, which is x is greater than or equal to 2, or in interval notation, we have this. Okay. And now we're going to find f of g and the domain for that one. So we have f of g of x, and that's going to be f of, and then I put in my g of x, which is x squared minus 1. And then I go to my f. Wherever I have an x, I'm going to use parentheses. So that's my f, and I'm going to drop into that this guy. So x squared minus 1. And now I need to simplify. And when I simplify, I get x squared minus 3. Okay. Now we have that. We can find the domain. When I'm finding the domain, number 1, I'm going to find the domain of my inner function, which in this case is g of x. And that is going to be the domain of this here, and you don't have any variables in the denominator. We don't have any variables in the radicand, so we would say all reals. Okay, and then the second piece here is going to be that we find the domain of the simplified composite, and so that is going to be this guy. Okay, so find the domain of square root of x squared minus 3. So when we're finding the domain of that, we know that x squared minus 3 has to be greater than or equal to 0. Now, this is going to factor as a difference of squares. The square root of 3, it's not 3 is not a perfect square, so we're just going to write x minus root 3 and x plus root 3. And then we had a quadratic with an inequality. That tells us that we're going to have to use a number line. And I have negative root 3 and root 3 as important points there. I choose a test point. Maybe I choose 0. If I put 0 into this guy, then I get 0 minus root 3 is giving me negative root 3. If I put 0 in the next one, I get root 3. And is that greater than or equal to 0? Well, it gives me a negative, so the answer is no. So this area doesn't work. I know that this does work, and this does work because of the equality. Now I choose points on each side, so maybe I choose something like negative 3 over here. If I put in negative 3, then it's going to give me a negative. And if I put negative 3 into this one, then it's going to give me a negative. And a negative times a negative is greater than or equal to 0. So it works here. Choose a test point on the other side. It actually works there. So just like last time, when you're finding the domain, and one ends up being all real numbers, you go with the strictest of the two. We don't have to, in this case, there's the intersection. So if I were to graph all real numbers, it looks like this. So the intersection is simply going to be where the red one is. Okay, so we just need to say our domain in this case, an interval notation, is going to be from negative infinity up to negative root 3, including that negative root 3, and from root 3 to positive infinity. And that's all I have for this section.